In a groundbreaking scientific breakthrough, the James Webb Space Telescope, JWST, has done what was once thought impossible, capturing the very first image of another universe. This revelation marks a turning point not only in our understanding of space but in the very fabric of cosmology, physics, and the nature of reality itself. The concept of a multiverse has long been a theoretical staple, often discussed in academic circles and popularized in science fiction. Yet, to many, it seemed an idea rooted more in imagination than scientific possibility. That is, until now. This discovery has stirred excitement in the scientific community, and the image, taken from a distant point in our universe, provides humanity with its first-ever glimpse of what lies beyond our cosmic boundaries. The implications are profound. A confirmation of the multiverse theory would rewrite the history of scientific thought and perhaps unveil new laws of physics. But how exactly did the James Webb Telescope achieve this, and what does this mean for our understanding of reality? ######, the journey of the James Webb Telescope, a technological marvel. The James Webb Space Telescope, JWST, launched on December 25, 2021, has been hailed as the successor to the Hubble Space Telescope. Unlike Hubble, which primarily observed the universe in visible and ultraviolet light, JWST was designed to focus on infrared wavelengths. This capability allows it to peer through cosmic dust clouds and see objects that are too distant, too faint, or too ancient to be seen by previous telescopes. Essentially, JWST acts like a time machine, looking back to the earliest epochs of our universe. One of the JWST's key missions was to examine the oldest stars and galaxies formed after the Big Bang. But its unprecedented sensitivity and resolution have surpassed expectations. Earlier this year, JWST captured images of distant galaxies with unprecedented clarity, giving astronomers a better understanding of the universe's evolution. However, no one could have predicted what came next. ######, the accidental discovery. A glimpse of the unknown. Initially, the James Webb Space Telescope was being used to study a particular galaxy cluster approximately 13 billion light-years away. This observation aimed to investigate the formation of some of the earliest structures in the universe. While analyzing these images, scientists noticed an anomaly, an area of space that did not behave according to known physical laws. At first, the anomaly seemed like a minor glitch or an unusual distortion in the fabric of spacetime caused by gravitational lensing. But upon closer examination, it became apparent that this was no ordinary phenomenon. The light pattern did not correspond to anything we'd previously encountered. It was as if the image was peering into an entirely different region of space, one that didn't follow the conventional rules of our universe. Dr. Emily Carter, a leading astrophysicist on the project, described the moment of realization. "We thought we were just looking at a distant galaxy cluster, but the data didn't match what we expected. After ruling out all possibilities of error, we realized this could be something much more extraordinary, possibly another universe." #####, what is the multiverse theory? To understand the significance of this discovery, we need to explore the multiverse theory. The concept of a multiverse suggests that our universe is just one of many that exist simultaneously, each potentially governed by different physical laws. While the idea has been explored in various forms throughout history, it gained more serious attention in the context of quantum mechanics and cosmology. One of the leading models of the multiverse is based on the concept of cosmic inflation, a theory which suggests that in the very early moments of the Big Bang, space expanded exponentially. This rapid expansion could have led to the formation of multiple, isolated regions of space, each representing a separate universe with its own unique characteristics. These universes are thought to be disconnected from one another, existing in parallel, and largely beyond the reach of direct observation. For decades, scientists have pondered whether it would ever be possible to prove the existence of these alternate universes. And now, with the first image captured by the James Webb Telescope, the idea of the multiverse may no longer be confined to speculation. #####, analyzing the image. What does another universe look like? The image released by the James Webb Telescope is unlike any other cosmic image we've seen before. While previous images captured galaxies, star clusters, and nebulae, objects that are part of our own universe. This new image shows something altogether different. A series of patterns and structures that don't conform to the traditional forms of galaxies or stars. Scientists have described these patterns as alien geometries, structures that, while visually striking, do not fit any known cosmic formations. The laws of physics in this alternate universe seem to operate differently. Light behaves in unexpected ways, bending and warping through space in patterns never before observed. Colors in the image also present unusual properties. Rather than the typical redshift or blue shift that indicates objects moving away or toward us, the colors suggest a different kind of motion altogether. This other universe may have a different type of matter, energy, or even fundamental forces. The very building blocks of reality, atoms, particles, and forces, could be entirely different there. Scientists are now working around the clock to analyze the image and extract more information about this newly glimpsed reality. Could it harbor life? Could its inhabitants have developed civilizations? These are just a few of the tantalizing questions that have arisen from this discovery. ###### implications for physics and cosmology. This discovery poses a wealth of questions for theoretical physicists. For one, the existence of another universe challenges the idea of a single, all-encompassing theory of everything. Until now, physicists have been working towards understanding the four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces, and how they interact to govern the universe. If other universes operate under different physical laws, this might mean that our attempts to develop a unified theory of physics are inherently limited to our own universe. It also raises profound questions about the nature of time and space. In this newly observed universe, time might flow differently, or space might curve in unimaginable ways. Could this universe be older or younger than ours? Is it expanding, contracting, or perhaps existing in a state of equilibrium? The possibilities are endless. Moreover, the discovery could provide insights into the nature of dark matter and dark energy, two of the biggest mysteries in modern cosmology. If different universes have different amounts of dark matter and dark energy, studying these variations could offer new clues about the roles these invisible forces play in the cosmos. ##### challenges in understanding the image. One of the primary challenges in interpreting the image lies in the sheer strangeness of it. With no precedent to rely on, scientists are in uncharted territory. Standard methods of astronomical analysis, such as redshift measurements, spectral analysis, and gravitational modeling, may not apply in the same way to this alternate universe. Some have proposed that artificial intelligence and machine learning could assist in analyzing the image, allowing computers to detect patterns that human eyes might miss. Others argue that we may need to develop entirely new mathematical frameworks to understand this foreign cosmos. As exciting as the discovery is, there are also concerns about the potential for misinterpretation. What if this universe is simply a bizarre aspect of our own, previously unknown to science? Could this image be revealing a rare but natural phenomenon within our universe that we don't yet understand? Only time, further study, and more images will provide clarity. ##### The search for more evidence. The scientific community is now eagerly awaiting more data. If the James Webb Space Telescope could capture another image of this parallel universe, or even detect more universes, it would lend immense credence to the idea of the multiverse. But even if this proves to be a singular discovery, it has already altered the course of modern cosmology. The search for other universes is not limited to space telescopes. Researchers working with particle colliders, such as the Large Hadron Collider, LHC, are also exploring whether collisions between subatomic particles might provide evidence of parallel dimensions or universes. If such experiments succeed, we may soon have multiple lines of evidence pointing toward the existence of a multiverse. ##### conclusion. A new frontier in science. The release of this image marks a pivotal moment in the history of astronomy and physics. For centuries, humanity has looked up at the stars and wondered whether we are alone, not just in the universe but in the grander sense of existence. Now, we are on the verge of confirming that our universe is just one of many in a vast multiverse landscape. What lies ahead? The answers are as limitless as the universes that may exist beyond our own. As the James Webb Telescope continues to explore the cosmos, humanity stands on the threshold of a new era in which the unimaginable becomes reality. The discovery of another universe is just the beginning.